we go. So welcome everybody. It is the 8th of August and this is the regular monthly meeting of the Dallas Persional Robotics Group. We normally have people from all around the world. Who knows where we're all from today, but we're here. So today we have a presentation from Ron and Will on a line following simulator written in processing and then putting it to use in a physical robot. So let's, without any more delay, let's take a look at what there is to show. And with that, Ron, the floor or the screen or whatever we want to call it in these COVID times is all yours.
Okay, well, the big problem we have right now, oh, okay, now I'm offered, okay, present now. Okay, hang on. And let's see if I can recall the window 1 second.
I had stolen the presentation screen from you temporarily.
Okay, so we're looking at, hang on, let's see, I can see what I'm presenting 1 second. Ah, very good. Ah, okay, this is a line following simulator that I was, I guess, motivated really by Dave Ackley. If I'm not mistaken, I told Dave that I would create a simulator and he asked if I could do it in Python. And I did write a rendition of it in Python, but then I've done a little more work on it in Java. And then Will has kicked in and has written the starting of an advanced line following controller for the simulator. But let me kind of give you a little background on the simulator and how it works. And the idea is to provide a simulator that gives you the ability to drive a robot around on an image of the contest course. In fact, I'll put that up as far as here is a challenge course. And first we go into is how do we orient the robot and so forth. So here we have a image of a challenge course, and this has been produced at 64 dots to the inch. And this image is actually loaded into the graphics processor when you execute the processing application and is rendered in such a way that based on the position and heading of our robot, we produce a view or an overhead view of the robot. And the idea here is that given a robot that we provide velocity and turn rate information to, it drives around on the course, produces images, which then we can interrogate via virtual sensors. And with that said, really, given our drive commands, we get sensor information, and then we can write our controller for it. And the model that I've used is a differential drive robot. But let me first discuss, here is an example of the course. And the upper left-hand corner of the course image is treated as the world origin, or 0, 0 in Cartesian coordinates. And then the x values run along as we read to the right on the image, and the y values down. And here I've given you a sample, and everything's in inches. The tiles are 12 by 12 inches, and there is a 6-inch border on this course. And so here's an example of the starting line centered on the line itself is at 4812. So the x value is 48, and you can see here is 1, 2, 3 tiles. That's 36 plus another half tile, 6 more, and then the border another 6, and that's 48. And then the y distance is 12 inches, 6 inches for the border, 6 to the middle of the tile. So here we are with a starting point for a robot, maybe slightly different than this, maybe forward a little bit or back a little bit. But anyway, you kind of get the idea of the coordinates there. But let me move ahead to the robot, which we have to kind of also understand the heading of the robot. And again, my model is a differential drive robot. Will's is a tricycle robot, and both options are present in the simulator right now. But as far as the differential drive robot, what you have is a heading that defaults 0 is facing as the direction you see toward the end of the, well, it's in the direction you would travel on the challenge course, I guess to say that. So in other words, traveling in the negative x direction in world coordinates. And the turn, a positive turn rotates you, if we were standing above the robot or standing behind it and looking down on it, a positive turn rotates you to the right, or what I would call to the right clockwise, or a negative turn rate would turn you toward the left. So you would move from heading 0 to 359, 358, you know, over eventually to 270 if you were facing in this direction. So that's the robot heading. And then from the standpoint of what we see in the simulation is we don't see the robot because really, as far as the simulation is concerned, we're interested in placing sensors and reading those sensors. And in this case, or in this simulation at the moment, the types of sensors you have access to are spot sensors, which it might be the most primitive type of sensor. And the spot sensors can sample a rectangular area of the course, and it just depends on how big of a sample area you want. But at the moment, we sample a rectangle, and that sensor returns, in this case, it's looking at white background. This sensor would give our program a 1.0 reading, whereas this sensor here in the center would give our program a 0 reading. And if the sensor was located part on the line and part off, we'd have some value between 0 and 1. So the larger the area we're sampling, then the more opportunity to see a piece of the line. So let's see. Also, we have a line sensor that is composed of effectively an array of these spots, and they're placed closely together. In fact, they are adjacent regions of pixels. And in this case, the information we'd get back would be all ones for these cells, then zeros for these, and maybe the ones right on the edge would have some intermediate value. And in my example controller, which I'll illustrate in a few minutes, it has the ability, just a simplistic program that will tell us the centroid of the line. Actually, if the line is centered as it is right now perfectly, we would get a 0 value. And then as the line moves off to one direction or the other, we get a signed value of the centroid read by that line sensor. And I'll illustrate that in just a bit. So anyway, oh, and here we can actually see at the bottom of the screen an illustration of this line sensor. And here you can see colored in white and black. You can see white values there, and it looks like pretty much the values there are black, and it's not lined up exactly with the center of the screen. And I should note, when we're just setting up our robot, really the size of the robot isn't taken into consideration for this differential drive robot because, well, one, the only thing we're doing is we're driving at a given velocity and a given turn rate, and I'll illustrate that in a second. But the coordinate system you see here is the center of the robot, and at this origin here. So what this is used for is the positioning of our sensors. And for example, if we put a sensor right at the robot origin, that would be 0, 0 in robot coordinates. But for example, these sensors are located about 1 inch in front. This one has probably a y coordinate, which is this direction, of probably about minus 1.5 inches, and an x coordinate of about 1.0. And this line here, this line sensor, is located about 2 inches forward of the origin. So I think we've seen most everything here. So let me go ahead and really kind of demo the thing so you can kind of get an idea. Here we're seeing an overhead view of a kind of a mock-up of an advanced course. I don't know if advanced course has intersecting lines, but this is close to an advanced course. It might have some features that are not, strictly advanced features. But anyway, the way the simulator works is we do have access to an overhead view of the course, And this also allows us to see a cookie crumb trail, and I'll show that in a second. But first, let's tab to the robot view. Oh, and by the way, here we have a panel, and I can make that panel opaque, or I can make it semi-transparent. So I'll leave it opaque for a second. So I'm going to tab to the robot view, and here we are in some strange location. I'm going to reset, and let's see. And I'm going to, hang on, I'm going to restart the program. Here we go. I'm not sure where we were in space. Oh, I know. I'll explain in a minute. I clicked on a location that took me somewhere else in the course. Okay, so here we are ready to start. And this location is programmed into the simulator as a starting location on this course. And first what I'm going to do is just manually drive the robot. Oh, and let me just stop for a second. Am I doing okay? Does anybody have any questions? Or if you want to interrupt me, that's fine. I could take questions, or I can wait and talk more. What would you like?
Ron, I see an inconsistency. Your starting location is not including the border on this screen, as opposed to your file. You showed it at 4812.
Oh,
it's a minor thing. I'm just pointing it out.
Oh, okay. Let me, yeah, the thing is, what we're seeing here is an overhead view of the robot location. And really, the only thing it shows us is the center of the robot and the location of the sensors. And it does show us what the line sensor is seeing. The point sensors aren't displayed. That's a future thing that might be nice. Anyway, so at this point in time, let me just start driving the robot. And so I'm going to press the up arrow, and let's see, is that, you know, I don't know if that is actually talked about. I might be missing that from this key summary. Oh, it was plus and minus for velocity, but actually it's up and down arrows. I think due to a request, maybe Dave Ackley or somebody. Okay, so if I start moving forward, you can see we're just driving the robot forward, nothing very exciting, but I can turn the robot. And in this case, the turning in the manual mode is an increment of, I think, well, let's see how many degrees. It looks like 5 degrees. And so I can follow the course. And again, what we're seeing is the perspective from locked above the robot. So the world rotates below us. And if I stop, for example, if I stop the robot, then the world rotates, if I turn the robot, around the center of the robot. So you can see that origin of that XY, that's the center point of the robot, and that's pretty much between the wheels. So anyway, let me go back to the beginning, and actually I'll illustrate then my controller running on this. So I'll stop. Oh, there it is. The space bar engages it, but let me reset. And in this case, I'm going to turn the controller on, and I am manually controlling velocity. So it's controlling the steering, but I have the up arrows. I can control how fast it runs. So let's see how fast we can go before it blows up. Now, of course, this robot has the advantage of it can turn. Whoops! It missed that. The broken line killed it. So that was too fast for that. But in fact, I'll tell you what. I'm going to go in, and I'm going to enable the robot's automatic velocity control. And I'll kind of show you the code that I'm manipulating here. And I'm not going to go into detail. This is my differential drive controller. And in fact, it's very simple. Basically, I control the robot turn rate and velocity based on a centroid, or the number that's the center of the line with respect to my robot. So I have a method or a function that basically scans the line sensor, determines where the line is centered, comes back with the value. So that's this statement right here. And with that statement executed, then I can calculate my turn rate and velocity that I need for my robot to drive. Now this is happening at about 30 to 60 times a second. And in fact, the other information I do have here is the amount of time that's elapsed. I call that DT, and that's in in seconds. And actually, if you want, you could actually fix that DT to a value, but I'll go into that later. But anyway, I re-enabled my automatic velocity calculation done here. And now I'll move aside and I'll re-execute the sketch. And this is processing that I'm using here. And again, this is, you can download processing for free, and the sketch will have up on GitHub. So, okay, here we go. Let's start the controller. And again, the space bar starts the controller. So let's see how my controller does. And while my controller is running, I can tab to an overhead view. And we actually can see cookie crumbs of the, and let me get rid of the panel. But you can see the cookie crumbs as the robot drives. You can see the cookie crumb trail and how well the robot's tracking. And in fact, I'll get rid of the, in fact, let me, I'm going to move the sensor back to the center of the robot, because there I noticed, and Will can explain some of that probably fairly well, but that the robot becomes very unstable. So here I have a very high gain, and it might almost, oops, it did go the wrong way on that intersection, so it's retracing. But let me make a change here, and I'm going to eliminate a derivative term. No, I'm sorry, I was going to reposition the sensor. Let me do that. Oh, so here we are. The things really that you have to set up for this program are you define your sensors, which in my case, my robot has just one sensor that's defined out here. I'm going to move it to the robot origin. And let's see how the behavior changes on the robot. So now I'm going to re-execute the sketch. And then I'm going to turn on the controller, pressing space. And now, look at how crazy it is. Let me tab to the overhead view. Whoops, you see how it was oscillating and it went crazy. So the positioning of that sensor radically influenced the behavior of the robot. And this is not unlike what I've experienced in the real world. The simulations maybe not exactly real world, but boy, it's amazing. So there you go, very unstable. And in fact, just for fun, let's move it just to an intermediate place. Let's see if it's stable at that point. It's just slightly forward of the center line. And whoops, here we go. And it's not as stable as when it was further forward, but it's not bad. Anyway, that's an example of the simulator. So again, what this handles all the visual stuff and the sensors. All we need really do to use this simulator is we define our sensors, and in Will's case, he'll talk to you about how he's defined a line sensor and then multiple spot sensors. And here you can see, in fact, if trike mode, that's his controller running. Then he defines several sensors, but in my case, and the suggested beginning point maybe to play with this is turn trike mode off. And that constant is set right at the beginning of the main program. And here's a Boolean, false, trike mode is off. Other than that, if you want to design your own courses, I'll probably have a few more notes on that, but the course gets loaded. And here, if trike mode, I'm going to load Carl's rendition of the challenge course in the case of Will's robot. In the case of my robot right now, I'm loading a different image and then positioning my initial position of the robot specified here. So we load a course, we specify an initial position. If we've played with the resolution that the course has been created at, you need to set your course resolution. Then we define our sensors, and then we write our controller. So, and again, in my case, the controller is really one routine that can determine the centroid position of a simple line, and that might be a good starting place. So really, the controller code that I need to write for the robot is here, and then all I really need to know how to do is operate the program, which is just simple keystrokes, you know, with, in this case, whatever, up and down arrows, and I believe if it's still there, no, plus and minus, so that's an error. That should be up and down arrows there. But we have the ability to stop, the ability to reset back to our starting point. We have the ability to, you know, change our panel visibility with P, our tab to toggle the course view, and then one other thing that I didn't discuss is we can click on a place on the course where we want to position the robot. And then if we go back to the robot view, we'll see we're right there. Now, one thing I'm lacking here is orientation. You might need to manually orient the robot. But then at this point, I could start the controller and you know, continue from that point right there. And I believe if I press reset, it'll take me back to that place. Come to think of it, I'm going to make a note. When I press reset, it would be nice to have the orientation that I had before I started the controller with the space bar. But anyway, that's it for my my words on the simulator. And with that, I guess if there's any questions just about the basic simulator, but then after that, we'll let Will take over.
Hey, Ron.
And that's pretty cool. So you got just 1, 2, 3, 4, 5, 7 files in your processing sketch?
Yes. Oh, yeah, I can go over that. Good, Carl. Yeah, the goal was to make something that a single human can understand. And this does not have some of the cute features of like my simulator that does a full rendered 3D camera view. You know, that is a more complicated program. It takes a lot longer to understand. But in this case, this program is, I think, a single human can grab it pretty quickly. And let me go through kind of the bits of the program. Of course, we've been looking at the controller code here, and this is the code that you would write as a user or modify. You know, a good starting place is to get in and modify this or play with this controller. But the other parts of the program that you might have an interest or a need to modify, in this case, there's a tab here that contains basically key press commands, and I think this would provide a reasonable enough template. In this case, a lot of these commands are oriented toward manually driving the robot. Will's robot is slightly different than my robot, but not too different. I think in his case, he controls the physical steering angle of the wheel. In my case, I control a heading. Oh, actually, in manual mode, yeah, I physically orient the robot or increment the heading. And I don't control the rate, whereas in my controller, I actually control the turn rate. But here, a key press physically rotates the robot 5 degrees. Then the other keys, for example, I was using spacebar to enable and disable the controller, so you're seeing that. There's a key to display the panel or toggle it through opacity from transparent to opaque. So you can kind of get, okay, so here's all the stuff related to keystrokes. And I think I make mention, yeah, when we clicked on the the course view, that gave us the ability to position the robot, and that is done in a different module. But anyway, so that's key input. The robot itself is a class that's defined, and here we have the position, the heading, the turn rate, and the velocity. Then there's a few different variables for Will's tricycle model. And in this also handles crumbs, cookie crumb drops. And cookie crumbs are dropped with a threshold of 0.25 inches. So this keeps you from generating, you know, millions of crumbs if you stop your robot or whatever. But anyway, the Java constructs or bits of Java aren't that complicated that I'm using in this program, I feel, at least reasonably. If you have a grasp C or C++. The low-level Java syntax looks like C, and the only thing that would cause you some need to research would be things like, okay, what is a how do you define a list in Java? And I think this is going to look a little different than in C, or an array. And there's examples in the program of arrays and lists, but no really fancy stuff. Let me think. So beyond this, we do have Draw World is the stuff dedicated to physically drawing the robot's surroundings, or that image of the course that's rotated and translated into the robot's coordinate system. And that requires a little bit of knowledge of 2D graphics, and I was going to discuss this, but I think I'll save that if we ever want to have a little micro talk on maybe how to do coordinate rotation and translation and scaling for an application like this. I could talk about that, but for now, these are processing function or method calls that help realize the robot drawing. And the neat thing is you don't need to know anything about that to use the program. So, this is more or less you don't need to mess with unless you just want to get into it. The robot module you really don't need to mess with unless you want to build your own different kind of robot. The sensor module is really something that the only thing you need to know is how to read the sensors, and I would look at the controller code for that. So this part of the code is actually what samples the screen image. So in other words, every frame that gets drawn as processing draws a frame. Oops, as we stop here, hang on, stopping, going crazy, controller off, wait a minute, reset. So as processing draws each frame, the sensor code interprets or reads right off the screen, really out of screen memory or the same frame buffer that's used for the screen, to actually physically sample the pixels. In fact, what happens is before I put these indicators here, I'm reading out screen memory, and then when I'm all done with that, I overwrite the memory with these that help us see where our sensors are located. So in other words, there might be 100 pixels here that are being read off screen memory to determine, where we are on the line or off the line. And then an average is being produced. So given if this box lie was halfway on and halfway off the line, you get a value of 0.5 for that spot sensor, for example. So there we go. So that's sensor, the robot, the key input, how to draw the world, our controllers, and Will will talk about his. And then in the main program, let's see, that's mostly comments. The main program is really just dedicated to defining the sensors. And then in this routine or this method called setup that processing calls first, and I believe that's similar to Arduino. I'm trying to think if they call it setup also, or what, I forget what they call it. But anyway,
they do call it.
They call it setup?
Yes.
Okay, great, forgot. It's been a month or two since I've done any Arduino stuff. So here's where we define the viewport size. Oh, and by the way, so we could set this bigger. In fact, just for fun, I'll try, let's see if we can do full screen here, screen. See if that works. Looks like it needs to be a mixed case. Whoops. So that's it. You can define the resolution. Whoops. Oh, hang on, I'm having difficulty now. You can define a screen resolution for your sketch, and I'll come back to that in a second. But okay, so here we defined our spot sensors, and then the draw routine is equivalent to loop in Arduino world. And in this case, this is executed about 30 to 60 times a second. I think on most moderate graphics cards, 60 frames a second is the typical. And really, in this routine, all we're doing is we are measuring how much time has elapsed between the last frame that was rendered. But we can, if we want, fix that amount of time. This will cause, if our frame rate is varying a little bit on our graphics card, it'll just go ahead and render the frame, but it'll lie to the simulator, and it'll set a given amount of time. And what that would do is that it does give you the ability to even make the simulator more finely grained. We could set the simulator, for example, to a millisecond. And what that would do is the simulation would then move very slow. But every step through the simulator would now be, much finer resolution, if that was, something you wanted to do. Especially if you're dealing with sensors that are high speed and not like a video camera type sensor. Okay, so what else do we have to do? In our draw, we update our position of our robot, and depending on if it's Will's trike or my differential drive. Here you have two examples of updating the position of a robot. This code gets left alone for the most part, so again, you don't need to know about that. The next thing that happens in the simulation is the world is drawn at the current location of the robot. This produces the picture for the robot sensors to then sample. And then, and I believe that also does the sensor update in there. We'll have to see if that's the case. I believe that's the case. So draw world draws it and updates the sensor readings. Then, if our controller is been enabled currently, we call our controller code, and that's the special stuff that you write in the controller. Those methods you would basically rewrite. In the case of the differential drive, you would rewrite this code or modify it. So then the rest of this is just to display status information. So you don't really need to know about it unless you want to modify it. So at the end of the day, it's all about you pick your sensors and where you want to put them and how big of an area the spots might sample, which it looks like 15 by 15 pixels is what we were going for most of those. And then, except for the line sensor, a smaller spot size was chosen of 5 by 5 per each spot. So that's pretty much it. Oh, and I was going to see if this will run full screen. Oh, wait a minute, it's not happening. Uh-oh. I ticked something off. Let me try, oh, it doesn't like that constant. Oh, I know, that's a function call. Tell you what, I'll just do this. Yeah, full screen is a method call. Anyway, we'll try that. Let's see what happens. Ah, okay. Well, it's kind of full screen, except it's drawing a border. Okay, I've got to do this. I'm obsessed. So now the simulation, oh, and it's displaying on, wait a minute. Okay, it's displaying on the wrong monitor. Hang on, I can do this. Let's see. Wait a minute. References. And I'm picking a different monitor. I'm going to try this. Okay, and one more try. 1 second. References. Got this at screen 3. Okay, there we go. So now actually the cool thing here is we're able to see a much larger area. So if we'll run the controller now. Wait a minute. It is a little slower, interesting. It's a little grainy, and that might impact the simulation. And that, in this case, that's sort of an example of if we didn't have a very good graphics card and we were noticing the simulation was bogging, what I'd be inclined to do is I would be inclined to fix this to a value. I'm going to make it a 50th of a second. And let's see, it'll slow down the simulation, but it should be cleaner and less jumpy. Let's see what happens. Well, still a little bit jumpy, but not too bad. But the cool thing is this is literally evaluating an image every 100th of a second. And that should allow the simulator to work better in this case where we're stressed on graphics capabilities. So anyway, but I'm going to switch this back to non-full screen for Will's presentation. Let's see, where is this? And by the way, these are all part of processing like these calls like full screen and size. there is a little dictionary of processing functions. And if you want to get into processing, you know, it has things to size your screen and things to draw lines and circles and everything. So that's all what you can learn by going to the you know, the reference, which is available, you know, either in this case it looks like it's offline. So when I'm not connected to the internet, I've got, you know, access to all the different processing method calls. So if you see something in the simulation that you don't understand what it is, it's possible, or a method call that's not defined in the program itself, it's going to be defined in this dictionary, most likely. Okay, I probably said enough.
Hey, Ron,
Yes.
I do have a question. I saw when you were looking at your controller that Will seems to have the wheelbase in his. Obviously, that would be a bit important thing in the differential robot too, but I didn't see it in yours.
Oh, it actually doesn't matter. In this case, because we're not concerned about individual wheel velocities. Now, if you wanted to implement a lower level implementation, but in our case, we're giving high level rate of turn and velocity. So we really don't care about our wheelbase. It's independent, given at that level.
I guess what I'm thinking is probably where you place your sensors then with respect to your center point in the wheelbase, because obviously if you have a big robot like a 15-inch robot,
right,
you're trying to turn on a 6-inch, you would have to turn one wheel forward and one wheel backwards. I guess I still think you wouldn't be able to follow a 6-inch radius curve. Do you follow me?
Oh, yes. Yeah. So there might be issues where, yeah, physically you'd have to consider the physical robot. I get you.
Okay. Cool.
Hey, Ron.
Yes.
Yeah, did you notice that the closer your sensor line was to the origin, you kind of got like an underdamped response? It would, you know,
yes,
kind of oscillate back and forth.
Yeah,
and
if I put it right in fact, if we put it right at the center line, and I'll just do that real quick. I don't want to, you'll notice that it becomes very unstable. So let's move it right to the center line. Did I do that? I can't remember. I think I did.
I don't know.
Yeah, so here we go. So here we have the sensor mounted right at the center line of the robot. So yeah, if we turn on the controller, you'll see it oscillate. And of course, if we go look at our cookie crumbs,
Yeah.
so there it is, crazy.
Unstable at that point.
Oh, say again?
So it looks like it's just going to become unstable at some point. Is, you know, if it gets too far off the line or
right,
correct too quickly to get back to the center. So it's
right.
Point, and I looked at the notes. There should be a distance where it's like critically damped, right?
Oh, now that's maybe, but I'm not gonna go there as far as Will could probably talk on that subject, but
Yeah.
I'm just a simulation guy. I don't know. I know nothing, but I did write this whatever. I think I did.
Well, I guess it would get you the best stability if you were critically damped, because you're not gonna overshoot or undershoot, or, you know,
right,
overbond or underbond.
Now, I do have in my turn rate, you'll notice so I have my current error, you know, a distance, or let's see, the offset of the centroid of the line as it intersects the line sensor. So I have that value. And if you'll notice here, I have a proportional term, but I also have a differential term. So this term right here, which is that value minus the previous error value times a constant. So this is a P and a D term for the turn rate. Now velocity, let's see, I guess my velocity, I tend to slow down the robot if my error is great. So that's that term. But we could just go with a fixed velocity too. That's an option. But in this case, my controller does control both turn rate and velocity.
So your PID values will vary depending on sensor placement, but I think sensor placement fore or aft of the center turning point of the robot is really more about where you have it in time, right? So it means that you're the further forward you are, the more time you have before your control point catches up with the sensor point.
Sounds reasonable to me. Maybe Will could comment on that.
No, basically moving the sensor forward introduces dampening into the system, and moving it back, when you go back to zero, you have no dampening. It becomes less unstable.
Okay, so Will, could I ask? If we did put the line at the center line, you feel like we could compensate with our PD controller? We could dampen it there.
I don't think you
That's
can.
what-
It's kind of like placing it after the point at which you traveled past it. There's no way to recover that information. Think of keeping going negative. It just doesn't help. So it's not really. I don't think of it as a dampening function. I think of it as you are sampling forward in time from where your robot is going to be.
Yeah, interesting. So in other words, the center point, the origin of the robot is in effect, the pivot point. In any instant right here, the center of our robot is, as we change our heading, that's our pivot point, if you want to call it that.
Yeah, and if you factor in real world lag, like reaction time from your PID controller to the actual motors and all that kind of stuff, it's your 0 point is actually forward of the physical center point of the axle.
Mm-hmm. So yeah, with the infinitely fast update and sensing, you could move this very, very, very close, but maybe you think you'd have a singularity if it's right at.
Yeah, that's right.
Okay.
Ron, let's run my simulation.
Okay.
Can you
So enough of Ron. Okay, and we're gonna switch over to Will. So okay.
Put mine on and start it, but don't press the up arrow. Just display it.
Okay. I'm gonna get there. So to enable Will's, we just have to change one value here, and it's going to bring up Carl's course, or the challenge course. And hang on, we're going to do that. And let's see. Okay.
All right. Well, let me explain a little bit what you're looking at. First off, I don't know whether you can see my pointer or not. I assume not.
Oh.
But you see that?
I can help.
See that narrow red line? The narrow red line is my robot. And the green line is a linear sensor. And the little green squares are spot sensors. And if you'll notice at the back end of the robot, there's a wide red section, and that's the steering wheel. And in the middle of that is a blue line, which is the position of the steering wheel if you're only using proportional control. To give you a little physical tie-in on it, I don't know whether you can see it or not, but here's my robot, and you're looking at the bottom of it, and this is the steering wheel.
Oh, now wait a minute. You'll have to present, or can you? Wait a minute. Tell me, are we seeing Will?
Well,
I see him as more than other people.
yeah, what you can do is if you can arrange your browser page to view all the thumbnails of everybody, then if you hover over Will's face, there's a push pin, and if you tap on that, it'll enlarge Will's image completely.
Okay.
Does everybody follow that, or anybody need more?
Yeah. Okay, that's
He is
good.
robot
So he
now.
okay. Cool. Okay.
And you can do that to toggle between anybody that's presenting whatever they're presenting. So, okay, thanks. Will, go ahead.
All right. Well, I don't have much on this, but like I say, this is my steering wheel. The red are my just idles. My line sensor is, call it a camera. It has a linear array, and then I plan to put my spot sensors in this area up here. All right, that's.
Hey, hold it a little further back. It's hard to see. Sorry, Will. Hold it back a little further so we can see the steering wheel. Okay, so that's the trike wheel, and rotate it. There we go. Okay.
And I guess is the steering wheel, is that the only one that's driven?
Yes. That's the wheel.
Interesting. Interesting.
And
it runs backwards. It's a backwards tricycle.
Yeah, the robot runs in that direction. The steering wheel and the wheel is behind. And go back to the display. And like I say, you'll notice that the red line is the robot itself, and the rear part of the line is thicker, and that's the steer wheel. And then the blue part is the steer wheel position when you're using only proportional control. So,
hey, can I drive it manually?
No.
Can I manually drive it first?
It's very difficult to manually drive, so
Okay,
I suggest we not.
Okay.
Suggest we not. I suggest hit the up button about twice or three times,
Okay.
and then hit the space bar. You notice that what the robot started off with the line, so it was heavy work. See, it's finally settled down pretty good. Now, basic what I do is that's an open loop maneuver. My philosophy is that I'm following the line as long as there's a line, but when I come to a continuity or something changed, by the way, hit the P button.
Okay.
That's a closed loop response, and that those closed loop responses are triggered by the fixed spot sensors. You'll notice that the sensor is almost always perpendicular to the line. That's the reason I'm putting my sensor back between the wheels. By the way, it is exactly on the line. I mean, on the centers. And you'll notice while it's kind of nervous, it is following the line. And it takes about 6 or 8 inches of travel to settle out. And I haven't been able to go the full distance yet, but I'm making progress on that.
Can I go to the overhead view so we can see how well it's tracking?
Yeah.
Okay.
Yeah.
Yeah, tight. Wow.
Pretty nice. Hey,
I'll go back to that so you can see it. Take the
the sharp screw.
Coming up to the acute angle. Oh no.
That's an open loop maneuver.
It did it.
So Will,
The open loop maneuver is over, so now it goes back to tracking. You notice it's taking a little to settle down.
So will the green squares, are those sensors really kind of offset like that?
Yeah, that's where it's located.
Huh. So how
No,
did
Will
you come
just had too much to drink when he was doing the sensor layout.
What's the
Well,
logic behind that dispersion pattern?
There's not much logic, I'm afraid. I just did different things to solve the problem. By the way, I want to point out one thing. When you're tracking around a curve, you'll notice that the robot is offset to the outside of the circle. That's because the steering angle is proportional to the arrow, and you have to have an arrow to maintain the steering angle to go around the circle. You'll notice. You'll notice that the proportional control is the blue line. By the way, that's an open loop maneuver there. And one of my reasons for putting the sensor behind or on the center of the center robot is that I want it to always be perpendicular to the line. And if your sensor is forward of the line, forward of the wheels, it's not perpendicular. Now there it wasn't very perpendicular because it wasn't going very close. But you'll notice almost every time it comes to a tile joint, it's almost exactly perpendicular.
That's clean.
As far as the cube maneuver, you notice that upper right-hand dot, not the very top one, but the far right-hand dot, that's the one that triggers the acute angle maneuver. And the rest of them keep that one from triggering falsely. Basically, what you have to do is you have to figure out how to trigger your maneuver and then how to keep it from being falsely triggered.
That's a clever approach.
Well,
Does each dot trigger a maneuver, or maybe a pair of dots, or
no, it's different maneuvers are triggered by different dots, whether they're on or off.
So Will, aside from the PID loop, does your controller have any concept of the prior image frames, or is it only looking at the sensor state at a certain instant in time?
It's only looking at the linear sensor, and I'm not really using the PID loop.
Okay.
I'm trying to do what's called a state space design approach, and this demo here is a first crude attempt. The problem with putting the line sensor at the wheels is it has no dampening, and you have to provide the dampening. And because the sensor itself is made up of individual, there it killed itself. You can stop.
You made it pretty far though.
And one of the problems I run into is that the line sensor is quantized, and so the output of the line sensor, not a continuous smooth curve, it's a staircase. And when you differentiate a staircase by taking the difference between the current and the past reading, you get a bunch of spikes more than you do anything else. So I have developed a controller now that uses what's called an observer to calculate what is basically the derivative. And once I get that a little more refined, I'll have Ron publish that. But well, it looks like it's failed again.
Yeah, we reset it quickly.
My goodness.
My approach has got problems, but it shows promise. So
At this rate, you're going to conquer the course by the time we can lay it out physically again.
Well, if I keep on it, I may get it in a couple of weeks. I don't know.
You're doing great.
I'm going a lot faster here now. Just for fun. I cranked up the speed, Will. I know.
The things I'm trying to do is most controllers use time as the independent variable. I'm trying to use path length as the independent variable. So when I speed up or slow it down, I don't change any values.
It seems like your robot's anticipating the acute angle before it gets there. Is that right?
Yes, it is. That
Okay.
that upper right-hand corner,
Oh, okay.
right.
Your sensors. Okay, yeah.
upper right sensor.
I guess I was just
And
looking at the sensor line, not the other. It's like, wait a minute, how's it doing?
Okay, here's a question. Can it go backwards as well as it can go forwards? I mean, if you put it as far as it got and turn it around.
I gotten this robot to physically do it, but my previous robot, T2LS, had the sensor between the wheels. And yes, you could set it on the course. In fact, I had it set up where it set on the course and it would go around. It was a loop course. It'd go around the course, and after the time, the motor would reverse and it would go around the other way. So it'll track either going forward or reverse.
Nice.
Have you tried turning off the line sensor and just using the spot sensors?
No, there's no. I don't get any. All the spot sensors do is trigger a open loop maneuver, which is basically the code is kind of a finite element. I mean, a finite state machine. Once it triggers, it goes through the finite state machine to move the controls until it gets through the maneuver, and then it goes back to tracking.
So as
Would
I've
still
heard-
be interesting to see.
What?
It's like the hand of God maneuver. Comes in and grabs it, moves it.
Yeah, as I've heard some people in the club, when it's open loop like that, it's not really following the line. But I think that's only a purist view.
Well, I'm going to be a purist and say there's not a line there. You've got
There you go.
the course is a collection of line segments, and so what do you do when you come to the end of a line segment? If there's another line segment touching it, you can go ahead. But when it's offset, how does you know whether to offset it? So
Oh, I agree with you. I'm just saying those purists were abusing me. That's all. So I wanted to bring it up.
I'd say that, kind of philosophy, your robot has to have some knowledge and prior knowledge. And the question is, am I incorporating, or are you incorporating any knowledge that's not in the contest rules? And by my reading contest rules, I'm doing everything that's required. There's, you talk about not following the line. I think when you come to a right angle, I think most of the people that are just trying to use a line sensor, they actually go beyond and lose the line. If they're going anywhere speed, and they go beyond the line and have to recover it. So they're not really following the line either.
Oh, yeah. Agreed.
So
I guess my thought on that is that if you can drop the robot down anywhere on the course and continue, then you're doing okay. but there's some obvious things that I think that you have to try to adhere to. Like you mentioned, Will, obviously, if you're going to a 90-degree turn, you can't stop in the on the exact spot, and not you're going to overshoot. So that's an okay. But if you go to a stain and you follow the outside line of the stain as opposed to driving across the stain, then that's a little iffy. Okay.
All right.
So I like what you're doing there for the acute angle. I don't see any issues with it. I mean, but the question, like I would say, is what I always felt was that the problem should be solved somewhat programmatically, and not so that a person says, okay, I go square one, I do this, square two, I do that, square three, I do that. Now I put him on square three and he's lost because his program won't work. Otherwise, as long as he can quote, follow the line, he's okay. But that's just, at this point, when was this thing done? Started in 2011. I just want to see somebody solve the problem. And I think there's some interest in it. Okay, go ahead. I'm sorry.
Well,
basically, what I hear you saying is that you don't want somebody to, in a sense, key in the exact path to follow, and then, from the start, you want to actually be tracking some lines or something.
Well, yeah, I'd like them to be able to take their robot, place it anywhere on the course, and it would work.
Right, or you could juggle the course around the elements of the course, and it would still be able to follow those elements regardless of how they were arranged.
Exactly.
Yeah, so that's the real aspect, right?
I really find Will's. I think anybody who's looked at this program really gets to the point where they do. I don't remember Will's word. I'm going to say, but it triggers an event. Otherwise, like I've come up to something that I'm going to have to do something, and I'm going to read what I can tell from my sensors and do what it's likely to be. And like Will said, you have to be able to trigger that event, but you also have to prevent false triggers of that event. And I think Will's got it, all the parts that I could think of. So, I'm just excited to see this much progress. And I also want to get a chance to use Ron's simulator. This one does seem more approachable than the 3D one. Not that the 3D one wasn't cool. It was cool too.
Well, I guess I have said all I want to say. If anybody's got any questions, otherwise, let's get on with the meeting.
That's pretty cool.
I have a kind of a left field question, Will. If someone's building a robot that's not using an Arduino language, but I'm writing mine in Python, how hard would it be to translate what you've done over onto a different programming language? Is there some way to kind of port this, or has it been done already?
I don't think it would be very difficult. Like I say, my actual line tracking algorithm, let's say it's not really a PID loop. It's what's called a space state approach.
Right.
And you need to know the states, and that's I don't think that there's any problem in porting that to Python. it's relatively simple. I hope to
Yeah,
help
I'm showing
publish
the
that.
code.
Well, unfortunately, that's kind of a hacked job there.
It's not that.
Murray, if you're interested in, I'll present my. I'll give you a copy of my it's C code.
Okay.
Basically, well, it's Java code.
No, that's fine. I program in Java. I guess the thing I'm thinking is that, like, I wouldn't try to emulate the hardware of your robot, but
yeah,
you know, you can buy, I think the Zumo robots and a few other robots, they have a little array of, like, I think 5 sensors that you can mount under your robot. And my robot's entirely physically different than yours. But if I was to, let's say, mount 5 or 7 sensors underneath, I'd effectively have a state array, and then I could start basically sampling off that and try to effectively do what you've done using a very different robot platform. And that's kind of what I'm thinking is, how would you abstract the kind of cleverness of this approach to a different robot?
Well,
code doesn't make any difference on that.
Okay.
Physical, as long as your sensors are placed the way you know, in the relationship to the wheels, I don't see any real problem.
Okay. So there is a way to generalize this approach. Okay. Thank
Yeah,
you.
but will he run into problems if he? I mean, you rely on having that line sensor, and in Will's case, he has like a 64 pixel or 128 pixel line sensor.
Mhm.
So
64.
does that give an advantage? 64. Okay.
yeah, my experience, because I've tried to, Murray, when this first came out way back in 2011, I actually made quite a bit of progress using a Pololu line sensor. I think it had 8 sensors on it.
Right.
Things that I found is, one, to truly be able to handle this, you won't be able to do it with the standard sensor that's on a Sumo, whatever that particular robot flat. You need a longer one, and you need one that's layered deep.
Oh.
Okay, and that's what you're going to have. So just having a line is, I mean, you can get, you'd be surprised how far you could go with that, but you'll eventually need that depth to be able to handle some special cases.
Right.
And
Right.
you also, because of the offsets and everything, the standard ones are about like this. Let's see if I can get this right. And you need this.
Mm.
So that's a real issue. That's why a lot of people have gone to cameras.
Yeah. I was
Because
just thinking.
the camera provides you both of those things. And anyway, that's it.
So if you were to use a camera, what you could do is choose a specific array of pixels off the camera and ignore the rest of the camera information and just grab, let's say, 16 or 32 or 64 pixels in an array off the camera and sample those.
Exactly.
As if you were doing it within a linear array.
Yes.
Yeah, that's been the approach I've taken. So that's kind of what motivated this simulator a little bit, except I simplified it in that I am using a look-down view instead of a camera-type view that's subject to perspective and all that. But really, this, I think, would be helpful in the case of my robot, in which I think I have my 3D simulation. Maybe it's actually completed the course or come close or something. But anyway, there I use a linear sensor, and a sensor I was going to add to this is a curved sensor. So it's an arc, effectively. So that might be one other sensor I'll add to the simulation, just because it brings it closer to the video line follower.
Hey Murray, I copied or borrowed some of the things from Ron. I actually used an upside down view of pixels in a 30 by 40 image, 30 pixels by 40 pixels. And you can select, you know, you can select whatever shape you want.
Right.
Best for your platform. And with a 30 by 40 image, it's much faster because you have, very low pixel count. It's only, I think, 12 pixels. So it works fairly well. I was kind of stuck before, I just, basically copied what Ron was doing at one point. I don't know if he's still doing that, but anyway, it works a lot better.
In one of my earlier experiments, I was playing with just a regular standard Raspberry Pi camera and learned how quite quickly, actually, just to grab one pixel off a 640 by 480 image. And so it would be, and I've got a place in my robot to mount a camera aiming forward, but I could just tip it down basically or at an angle. No, actually, you don't want it. You want it tip it down. I could tip it down and just select more pixels and effectively try to emulate what these guys have been doing.
Yeah, and that's what I did on this platform. The camera tilts down a little bit with respect to the base, and that's actually a wide angle lens, and it does distort a little bit, but it's kind of a trade-off between what size is the field of view of the camera with kind of a normal lens versus a fisheye or wide angle. But that's how I've gotten the farthest on it. I do have an issue with the acute line or acute angle, and yeah, pretty much the only way to get out of that is to try to sense it, and then I have to do pretty much a turn on one wheel to avoid other lines on the course. And but at that point, yeah, it is open loop. It triggered. It would trigger almost like a 270-degree turn, and so yeah, definitely.
I guess one thing I wanted to clarify, since I'm a little bit confused now, is it better to have the camera aiming directly down, or is an angle okay?
I liked an angle better. I got to see a little bit more forward, and one of the other features that's a little tough to get across is the gap. And if you can see the at the upper end of the image, that little piece of gap, the actual line, if you can catch that, you can get across the gap much easier because you are looking kind of down at an angle at it.
Yep.
So,
cool. Hey, can I interrupt just a second? I want to make sure, am I showing something other than me? Are you seeing?
looks like you're showing.
Okay, are you showing up right now?
You're showing Ray.
Yeah.
Okay, I just wanted to make sure that I wasn't screwed up and like you're looking at me instead of, I've been trying to click on the people and put their images up. That's why I asked.
Okay.
Well, we can also see them independently, so.
Yeah.
Okay, yeah, but I meant for the recording though, I guess.
You may not want to.
The recording tends to follow whoever's speaking unless somebody's presenting. Then that seems to.
Okay, so it's been tracking people speaking. I didn't need to do this cuteness of clicking on people's images and trying to get them on the presentation panel.
I think so.
While you're presenting, it shows your presenting screen, but if you stop presenting, it'll go dynamic and focus on who's speaking.
Okay, but so in other words, I should quit presenting then.
Right.
Stop. There we go. Now
If you're done.
Go dynamic. Okay, there we go. Oh, okay, I get it, I think.
Ron, I did have a question. Are you planning to keep this like pristinely virtual, or are you planning to add things like sensor noise and motion dynamics and that kind of stuff?
It's up to, I was planning on really not doing much more with it. That's certainly anyone's, I'll ship the code out there. If you want to add stuff, go for it. Mutate it.
Extremely bad lighting conditions.
There you go.
Electrical zaps now and then.
Yeah.
Hurricanes.
Wires.
If you could put it in GitHub,
Yeah.
that'd be great. We could put a link in with the meeting notes, or you could do your own
Okay.
GitHub, or there's a DPRG GitHub as well if you want to use that one.
Okay. Yeah, I'll. Doesn't matter to me. I guess I'll stick it on my GitHub if I can find it. It's been a few months. If there's a problem, I'll beg Carl.
Hey, no worries. I'll give you a hand if we can.
Okay.
We'll sort it out.
Okay. Hey, I just thought now we got time for people to do show and tell. Is that right? Yay.
Yeah. If we're all done with questions for Ron and Will.
Oh yeah. Are we all done with line questions?
One newbie question. Is this like a competition the club is doing amongst itself? I don't understand the context of what we've been talking about.
Yeah.
So I put in some notes in the chat there. I think Nihar was asking as well. So so this is the Dallas Persional Robotics Group, DPRG, and we meet every second Saturday of the month and pretty much every Tuesday night. We normally meet at the Dallas Makerspace in person, except for this COVID mess. So since March, we've been doing these meetings virtually. And normally what we do outside of COVID is that twice a year we'll have in-person contests. Typically one in spring is indoors, and then there's one in the fall that's outdoors. And we'll also do kind of community outreach. So we've set up tables and done demos at the Fort Worth Museum of Science and History, and sometimes at the Frontiers of Flight Museum by Love Field on Moon Day. So all of those physical things have fallen by the wayside, but if you look in the chat window for this meeting, you'll see some references to the DPRG website, where you can learn more about the club. There's a lot of experience, as you might guess, from the people that are typically on the call, and a lot of that's captured in YouTube. So we have like 300 some odd videos in YouTube for various different topics. And then for the contests, as a long way around to your simple answer question, there's a kind of a master list of contests that you can find on GitHub, and that's in the chat for this meeting as well.
It's also on the meeting. It's also on the website.
Yeah, it's also on the website
Go to
too.
the website and go to the competition tab, and then you can go to contest rules.
Yeah. And if you want to do the challenging line course or line following course, you either have to start out with about a lot of smack talk, or throwing a mitten on the ground. Either one.
Throwing a mitten.
Yeah, so the overall context was that there's this challenge course that evil course maker Doug came up with in 2011. Evil man, and nobody's really conquered all of the constraints yet. You're supposed to make it around this course in under 5 minutes without any human assistance. And a few of us have come pretty close with a couple of restarts in the middle of the course in 5 or 8 minutes, but none of us have really solved it autonomously. So, and then there's been some debate, because over the years, a lot of members will just build robots and try them out in the physical world. And then a few of us have actually started first in the simulator world, and then we head towards the physical. So for the last few years, as Ray mentioned, there's been a lot of smack talk about, oh, sure, that works in a simulator, but let's see it in the real world. So it's an interesting thing back and forth.
This group has smack talk? I haven't noticed.
Oh, boy.
I don't know what you're talking about, Carl.
Maybe we're well behaved on the recording, but nobody gets hurt. It's all good. So does that help? Does it answer your question about the context?
Yes, it did. And I can find the rules on your website, is what you're saying.
Exactly. Yeah, in multiple places. And they're, if nothing else, they're really good. You could think of them as a roadmap in a way, because, they'll give you little challenges to take on. So no matter where you are in your skills and experience, whether you want to focus on electronics, mechatronics, or more on software, you can find something in those contests and just pick away at it. And everyone on the call is welcome to help if you get stuck on anything.
Yeah, and actually there's three line following courses, the beginners, intermediate, and then the challenge. Doug, where did the challenge one come from? It came from a university, right?
Now, what it was, 1 year, we were not allowed to go outside. 1 year we were not allowed to go outside for some reason, our venue. So we tried to create an outdoor line following contest indoor that we could present. The original idea came from Carnegie Mellon,
Right.
where they do a freshman line following on a sidewalk that's between two buildings. And the sidewalk is all freeze damaged. It's bizarre. It's fun. You can go out on the internet and see people's runs on it. So we're trying to emulate that. That's where the stain squares came from. The stains represent frost damage that you would find on a sidewalk. That's where the bumps come in. That would be similar to the unevenness. All of the colors in line with, that was just evil. But, you know, it is what it is. And someday somebody's going to solve it. And it's going. I think, looking at the way the club's going, I think there's going to be like 3 or 4 solutions. Now, if we're in the show and tell, I got something to show. Okay.
Yes,
Well,
sir.
If actually,
Go ahead, and then I'll pull up the 3 different courses here, and I'll present them when you're done, Doug.
Okay, let me see if I can get this guy up. Okay. All right. Let me stop this guy. Or can you stop? I guess one. There it is. Okay. Let me go to presenting if I can figure out how to do that. Okay. All right. Let me pull this up now. Okay. You know, people know I've been working on a
Doug,
robot.
you presenting something?
Yes.
No.
You should see something here in a minute.
There should be like a lower right corner present now button, and you can select a window or a screen.
Oh, I thought I was doing it. Okay, give me a second. Oh, I see it. I got it.
There you are.
Okay.
It's up now.
All right. This is the first step of my camera-based one. You can see this is just a black line on white, so it's not super challenging. But it does mean that I had to learn how to set up the sensors on the camera and everything. So let's watch the paint dry. There it goes. So now,
Normal that it's a bunch of little squares that have been placed together.
yeah, this is our old style course, which used to be done on floor tiles with electrical tape. So this is the first step. If you notice, there's a white piece of paper in the middle that's underneath it. That's the actual first challenge course test pattern, which you can find out on the website in the GitHub. So anyway, so what I've got here is the camera actually reading the line and following it. Now, the thing that I'm finding, and I don't want, this is going to go around 3 times, so I'm going to stop it now. You get the idea. So, the thing that I found here that's going to be really interesting and probably taking into account some of my previous knowledge and what Will presented today, in fact, which is some good points that I had not thought about or had used differently. And but one of the things that I found is the real challenge is not so much the algorithm, even though that is a big challenge, and to get it absolutely right, it's a really big challenge. But what I'm struggling with right now is the actual consistent, otherwise, the best way to use the sensor, the camera to create sensors, because you don't want a single pixel to like throw you off into the Netherlands. You have to figure out how to get rid of the noise and the low lighting conditions, which are really, that's a big challenge. And that's what I'm working through right now. So I'm hoping that I'll have the black on white, white on black done by Tuesday. And then I can move, once I do that, I can move to where Will's going, and that's where you have events that you trigger for the ones that are particularly unusual. But we'll see. Anyway, so it's a start, guys. It's a start, and that's what I wanted to show. So I'm going to stop sharing now and turn it over to the next person.
Cool. Yes, looking good. Okay, I'm going to show just for reminder's sake. So where did it go? You should be seeing my screen at this point. Is that true? So this is the so-called beginner's course, and you can see it's just a little more complicated than that square rounded corner thing that Doug just showed. So it's a good entry level get started. We have a lot of elementary school and middle schoolers, kids do that. The next version introduces a little bit more complexity. It's still black lines on a white background, but you can see breaks and gaps and offsets. But it's a little more challenging. And as we've discovered by accident, putting this logo here, sometimes in the red lines, sometimes those are confusion. They are artifacts of how we made the course. So it started off with black electrical tape on floor tile, and now like there's instructions in the GitHub or maybe on the web space of how to take these SVG files and print them. So we print them on vinyl banner paper like you might hang for an advertisement outside a building. And these red lines and the other things were artifacts of that sometimes confuse the robot just to make it more challenging. And then the challenge course, so lots of people have solved these first 2 courses, and those have become basically a question of how fast can you do it, and can you do it multiple times in a row without crashing. And then this is the challenge level 1, so you can see it's quite a bit more difficult. It's basically 12 feet by 6 feet worth of course. It has all these little stains where the contrast is dark on darker and white on whiter, and changes of contrast and abrupt changes in. So this is quite and it normally starts here and just winds its way through. And there's some videos of several of us more or less doing it, typically less than more, but yeah, that's the challenge course that. And when Ron said Carl's version in his simulator, he was basically taking a variant of this, just a file that I had prepared, but it's the club's course. So get started somewhere, then take on a little extra complexity. And then if you want to drive yourself nuts for a couple of years, take that on.
Oh, the torture course?
Say what?
That's called the torture course?
This is the torture, yeah. Did I mention the word course designer's evil? But yeah.
So those files there are on the website?
Yes, they're all on the
Yeah, so if you go to the website
But
here,
there's also, if you flip over,
contest rules. And I don't know, is this a master list, Doug? I guess it is. It's pretty much of a master list, but just a snapshot in time. But then we do have also and that's dprg.org/contest-rules.
these get updated. They get updated to the latest version.
Say what?
These are updated to the latest versions.
These are the current, okay.
Yeah.
And then the current and history can be found here at GitHub under DPRG, github.com, DPRG/contests. And in here under line following, you can also find instructions on like how to print the courses. And we actually have some smaller courses if you want to print your own. It's like we found a place that does it for $1.50 a square foot. So so you can print your own and make your own, and there's instructions here on how to do that. So and then the source files, SVG files, and you can modify them if you can work with Inkscape and SVGs. And I think Ron also, in addition to simulator, he's written a course generator in processing. So you can and Ron, I muted you if you needed to say anything, but you can use Ron's software, wherever that is, to generate courses actually, if you want to use something other than one of our standard layouts. And I can guarantee you it's much easier to carry around than a bunch of floor tiles.
Amen. Now here, if you
I'll stop.
If you highlight me, I'll show here's some of the test courses. Okay, I don't know if you can see this.
Yeah, back off the camera, Doug.
Yeah, wait a minute.
Or backer. Yeah, there you go.
So these cost about $20 a piece, maybe plus or minus. So there's like one. That's the black and white on black. This is the next level up, which has several of the elements. Then there's one that has the really bizarre stuff here, stuff like this. This has stains and narrow and wide line, 90-degree lines. And then there's one more that has the acute angle, but I think it's put up. I don't have it out. So those are the different courses you can, like I say, you can, why these are good is because you can put them on a small 3x3 foot table, and you don't have to have a room that's 17 by 10 or whatever it is.
Yeah.
So it's a good way to get started if you want to just try one. There's even, I believe, there's one that's just black on white, but since I have those tiles, I don't use it. Anyway, that's all I wanted to show about the courses.
So we have some more takers. Anybody else want to try these projects out? Show us how it's done.
Well, I admit that I'm a little competitive. So when y'all said nobody's finished it yet, I thought, well, hey.
Can you be the first person to make the auto do it?
If anybody was talking to me, I was gone for a few minutes. So,
yeah, I have to admit, I've only been working on these robots for like 3 weeks, so I don't know if I could finish it. I'm competitive.
Well along the way.
You try.
Sounds like Mac talk to me. I don't know.
Oh, Ray.
Yeah.
Ray explained how the stains were made. So just check the chat if you're curious.
I saw.
Well, Dave, one of the things that I would see, the basic line following is a good way to get, you got to keep your interest up. You have to have a challenge. You know, your first challenge was to build the robot. All right, so now you got a robot. Well, you know, what are you going to do with it? Well, if you try to hit some of these contests, they really will help you. They'll help you grow, but they'll also keep your interest up.
I believe that.
All right. So does anyone else have anything interesting to show? I'm looking at Dave Steele's video, and there's quite an interesting feed there, Dave.
Yeah, sure. I'll show you something. Well, with this COVID going around, I thought, well, okay, how can you do something with the robots to do something for the COVID effort? So I'll show you what I'm starting here. 1 second.
It looks very sci-fi, very intriguing.
Well, there's a reason why it's that way. Well, I'm going to set my phone down. Let me.
I don't know if you can see it, but if you win one of the contests, you get one of Doug's trophies. So these are, kind of your badge of honor.
Okay.
Well, actually, those were started by Ron.
Oh, were they? Oh, okay.
Yeah. At least as far as I know, the first ones were by Ron.
Oh, okay.
Yeah.
I never got them from Ron. I only got them from Doug. So.
Yeah, this is, let's see here.
Yeah.
This is what Ron's looked like. They're Robbie. They have DPRG on the chest. And, but one year we wanted to do them and Ron said no. So we were kind of stuck. I think it was because he used such beautiful acrylic to do it. And I guess it was costing them bucks. Yeah. But we have a series of the different models that these are all clear acrylic, and a lot of them were actually made from scrap acrylic that was available from the makerspace. So that's kind of run out, but
like everybody else, I can see all those books behind people and stuff, but
yeah.
I've got a wall full of stuff where there's plenty of room to put things like that. I don't know if you can make that out on the.
You gotta have a trophy show.
Very
You
nice.
gotta have a spot to put things.
Yeah. Okay, so hey, so Dave, did you have it looked like you're setting up in the garage something to show us?
Yeah, I got my mobile robot. Can you hear me okay?
A little.
Yep.
Yep, it's pretty good.
Can you see?
Yeah.
If we push pin on your screen.
Okay.
Yeah,
but then I can't see.
what happened?
Yeah, it looks like a wheelchair plow.
I'm really curious about the welding mask here.
Oh, the video feed, I guess. Oh, now you're presenting. Okay, good.
Okay. Can you see it?
Now we see the email.
Okay, so yeah, it's a wheelchair filament background with UVC light mounted on top of it.
Dave, I think it's presenting the screen of your phone is what it looks like.
Yeah, if you stop presenting, we'll just get your video and then we can see what you're doing in the garage.
Yeah, so stop presenting.
Okay.
And then when you talk, then when you talk, you should take control and be recorded, and the rest of us can pin your screen to our. Okay, that's good.
Okay, you see it?
Yep.
Yep.
Good. Wheelchair robot.
Yep. So for right now, I'm just running it off of a remote control, like you guys were talking about last week. First thing is just to get the thing moving. So the idea is to be able to have a mobile set of UV light so you can move it down a hallway or something like that in a hospital room, hospital or somewhere like that, maybe even at your local Walmart, and be able to kill the COVID virus. The COVID virus is a SARS-type virus, and UVC is known to kill SARS viruses. They haven't done any studies yet on if it can kill the COVID or not, but they're pretty confident it can because it's able to kill the other viruses like
But even if you can't, you can use that as a portable sun tanning booth.
Well, no, you can't. And that's why I'm wearing the mask, because this is UVC, which UVC will cause skin cancer and can damage your eyesight and so forth. So you have to be able to filter out the UVC.
Should I be staring away from my screen then?
Yes, you should.
Where are your goggles and your mask?
Well, dude, you just gotta suffer. You just have to suffer for the tan, man. That's how it works. You just got to suffer for the tan.
Is that okay? So yeah, I just wanted to show you what I've been working on.
That's pretty cool.
That's pretty cool.
Thank you.
So how are you going to use that?
I haven't decided yet. I'd like to use it for donate it for a worthy cause. I heard in Dallas there's a hotel that opened up just for COVID patients, so they can get away from their families and recover. And I thought, well, maybe this would be a nice place to go to help disinfect that area.
There you go. That's nice. That's cool.
Where did you happen to find the UVC lamps?
I had to buy them from China.
Wow.
Yeah. They are available in the United States, but I believe they cost like $300 a piece.
Whew. Wow.
Cool. Well, thank you. So anybody else have something else to show for Saturday?
I got a little bit of progress. I managed to get one of these in the post, a little gamepad device, an 8-bit do. It's called an N30 Pro, and managed to pair it and get the signals off of it. And so I can now actually remote control drive my robot. So I'm sort of up to the point where I can actually move around, and it's actually using the PID controller. But I won't demo anything. I'll probably do a video at some point. Because what the idea with this is, I've been trying to describe the whole idea of the event loop that this thing goes through. Is the idea is I could use this as a series of low priority events and try to run the robot against a wall. And in theory, my infrareds would have a higher priority than the events coming off this. And the robot would then begin to ignore my directive and take the higher priority of infrareds. And that would prove that my theory is working. So that's kind of the next step in the next few days, is to see if I can run my robot against the wall and have it resist that directive. But that's coming along, and finally I got my game controller. It took forever to get here. So I'm coming along. It's actually, the PID controller's working, the arbitrator, the controller, it's all kind of coming together, but it takes a long time to write your own software, I think. That's coming along. That's about it from me.
I got a little progress.
Yeah.
Yeah. So let me present here for a second. No, I don't want to present my entire screen. No, you just click on me.
Yeah, we'll just okay.
Video.
We'll click on your camera. So we got you.
You got me? All
got
right.
your Raptor t-shirt.
Yeah. Raptor trainer. So
Excellent.
here I'm gonna switch you here for a little bit. So I have been mucking around by building on my robot. I got some stuff mounted. I got a plates mounted in the back here, so I'm going to put other stuff on top of it. I wired up my motors with the encoders finally, and I think you can see that thing bleeping along there. So I am talking to it, and I can do this now. That's not PWM. I can move motors, and if you're watching my screen, you can see I've got speed coming back to me and encoder values and current, and if I slow one of them down a little bit, you can see the current go up a little bit. And now I just need to decide how I'm actually going to drive the damn thing. You know, whether I'm going to do it in RC mode or do it in some kind of other way, because this controller, like I think Ray had pointed out, is really sharp, And if I put it in RC mode, it knows how to do differential between the wheels, and it makes basically one joystick input forward and back, and the other joystick input left and right, and then it controls the velocities of the wheels for me on the fly. And I think that's where I'm going to start. I'm going to play with it, but there you go. That's my update of Doom, so to speak, on the whole thing. Yeah. Can you see? Yeah. Oh, you didn't see quite all of it, but I got a little lower third here, trying to be cool with my my multiple window thing going on there.
You got the streaming routine going pretty well.
I've been streaming a lot. I'm trying to stream a couple hours like Monday, Wednesday, Friday on Twitch, and I've doubled my followers in the last week from like 11 or 12 to 22. And I figure that's pretty good. And of course, it's taken a while to get traction going on here. And I've got a couple of regulars show up. And so I don't know how far that's going to go and if that's going to be worth anything. But I started twitching myself, and I'm really surprised at the diversity of what's in Twitch, because I figured it's all Fortnite and PUBG and gamers, and that is the majority of it, the vast majority. But I was watching somebody in a game store repair Xbox 360s and that kind of stuff, figuring those things out, which was a little cool. And I got rated over to this very nice young lady who's doing mechanical keyboards and putting them together. And that everybody watches her do that. That's what she does. Why is it interesting? I don't know. But it was really cool. And they were putting them together and things. And then when we all there's like 130 of us that got raided into her channel at once. And so you can tell that you got hit on the raid. And so she stops for a second and she goes, oh, the raid's here. And she stops, puts an overlay on it. So it's kind of like zooming around, I don't know, some fancy street, puts the glasses on and gives us a little rap telling us who she is and what she does. And I'm like, I don't know if I'm ever going to be a rapper, but that's pretty cool. There's another guy out there who's pretty cool. He goes by Laboratory 424. And this cat, he's doing stuff with 3D printing, building projects, that kind of thing. But also in the back of his room, he's built a ping pong ball shooter. And in chat, you're able to issue a command in chat as to where to aim the pinball ball shooter. How to aim the pinball ball shooter and then when to shoot it. So you give it like an angle in a shot. It only works every so often. And every now and then somebody pops him right in the head. You'll see him talking to everybody shooting. He'll go, okay, wait a second, and bend over to one side, and ping pong ball flies past. That's some goofy stuff like that. Like, okay, that's kind of fun. But and then you got some other people that get a bit salty, and not necessarily everybody's cup of tea. But that cat is called Oh Bother, and he has a 4x8 sheet of plywood with a laser cutter mounted into it. And everybody that subscribes to his Patreon and that kind of stuff, he burns their name into the thing, into the plywood. That's his chick. There's lots of people with lots of sticks. Me, I'm just answering questions now and doing things, drawing and that kind of stuff. So
maybe he needs to monetize the ping pong ball gun, where like if you pay $10, you get to shoot 10 ping pong balls.
Exactly.
Rapid fire.
And there's a bunch of stuff I'm still learning. They got channel bits that there's some money kind of thing, and then you have channel points that you get so many points. Sometimes the channels give you extra stuff for doing things, and then you get merch from them or some other kind of thing. I don't know what all that's about yet. I gotta understand. I gotta figure out what all that is eventually, I guess. It's a problem I gotta figure out, but not what I want to solve. I really just want to build robots and share knowledge, And let's see what else. And I ran across this one cat. He's a paleontologizing, he says. That's his name of his channel. You're talking all dinosaurs and stuff. And I told him that the other day I went to a restaurant. It was staffed entirely by T-Rexes. The service was really, really slow. Seems they were a bit short-handed. I'm just saying. Yeah, you'll use it. You'll use it.
Harold, I'm still waiting until you start rapping. That's what I'm waiting for.
You know, Murray, be careful what you ask for. I'm just saying it won't be pretty.
I wasn't expecting to be pretty. I mean, come on.
So
Nice.
that's about all I had to share on my sharing things and that kind of stuff. And I actually had to go rebuild all of my stuff because it was crazy. I got a little lower third that you should be seeing my name and info
Yeah.
at the bottom of it, and rejiggered. My sound was bad and everything was going crazy. And so last weekend, I picked up a Blue Yeti microphone. I don't know how much. I don't know how much you guys do this. But it turns out I recommended this microphone to a friend of mine, and I asked him, it must have been, I don't know, a while ago. And I go, hey, man, I need a better sound thing. What do you think? And he goes, well, you recommended this Blue Yeti a while ago, and I got one, and it worked. How about you take your own recommendation? So, okay. Okay, so I did.
And it's working well.
I got that in an arm, and yeah, it's a really nice rig, and you can put it at cardioid, omnidirectional, stereo, and then one other thing on it. It's way configured that way. And the only other thing I've got coming, you can probably hear that when I'm tapping. Maybe if I'm tapping on the thing, you can hear that. I've got a shock mount coming and a pop filter coming for it too. So man, I'm actually going to be, I don't know, wired and fired to do something. I don't know. Semi-professional, yes, but I have no idea. I guess I can get a green screen, but I don't know. I kind of like the junk. You know, I do have some junk. I do a mess, and I need to clean it up. But I kind of like the junk in the background.
It's the lab.
It's the lab, exactly.
It's the lab for the professional voice, so you're good to go.
People works. Oh, thank you for that, Carl. But the people come to me and they say, "Hey, what are you doing, Tony Stark thing?" And I'm like, "No, not really. But if you want to think of me of that, sure." Hey. Now just to get my goatee back, you know, maybe grow some hair. I can't really do that anymore, but I can get a goatee.
You can wear a wig.
Yeah, I guess I could. I will tell you the weirdest thing about the Twitch thing. When I'm talking to you folks, I get to see reactions. I'm used to giving presentations and stuff, so I get to see reactions and stuff because I get in video feedback and body language and all those sorts of communication and avenues. When I'm on Twitch, I get a camera staring at me and a bit of text. So, you know, and it's a little bit delayed. It's a little weird on what do I say next, and did I push my joke too far, or is my joke actually sounding enough to them to actually keep continuing doing it, or should I go some other direction? I say not just joke necessarily, but just level of information. I mean, I've ran into about 3 or 4 other first robotic mentors. And we've had some conversations about that and that kind of stuff. And apparently me doing what I do here is kind of a rare bird in the Twitch thing. Most of them are chatting and doing, there's a few maker things. There's some of these electronics, crafty things going on. But by the vast majority, they're just people goofing around, doing stuff on playing games and that kind of stuff. And I'm trying to get enough followers and enough viewers at the same time to get involved. There's a live coder group, and they're live coding. They do all kinds of stuff, live coding, and there's like 150 of them, 200 in a group. And they will come visit you just because, and they will raid. And what a raid is literally at the end of my channel, I can say, hey, why don't you go raid my friend? And so I click until I send everybody that's viewing me to viewing my buddy over here, you know, because I'm done, you know. So once you go view my buddy over here, and they just raid all into it. So now you get all these people showing up in there that maybe you get some people hanging out longer. I don't know. Anyway, I'm trying to figure it all out. Again, a problem I don't really want to solve because I want to just build things and that junk, but it's a problem I need to solve. And I'm just kind of reinventing myself as a presenter. And how do I get messages out, and how do I, because I obviously can't go do this stuff in person, you know, I just can't. So I got to do something else different. Is this the avenue? I don't know, but it's the only avenue I know of at the moment.
You got it going.
Yeah.
You know, now let's look at Steve. So it looks like someone's got some fire going on somewhere. Plus a light show in the background. What's up with you, Steve?
So, Harold, if you want to spice up your live stream, check out this software. It's called Snap Camera.
Yeah, I've got it. I don't have it here. I have it on my laptop for doing work.
I like that one.
Yep, I have it on my laptop for doing work because I do all kinds of things. One of the fun one I have is I like the ascended one, where literally your eyes are glowing like you ascended, like in Stargate 1, where you went from a normal human being into an ascended state, that kind of stuff. Lots of fun there. Lots of fun stuff.
Excellent.
That's great.
Actually, have you checked out any of the Watchmen? The Watchmen ones where they got those. They're doing. I don't know if you guys are fans of the TV show The Watchmen, but they got a Watchmen overlay up there for SnapCam, and they did a really good job turning into Sister Night.
Yeah, I haven't checked them all. I just picked like 10 or 15 that I like. I switched.
Very nice.
That's very Texan.
That'll work.
Rick from Rick and Morty, huh?
Yeah.
All right. So what's this light thing going on behind you, Steve? Is there some kind of light display or something?
Oh, that's the LED matrix that I did a while back.
Just have it running. Yeah. Okay.
Oh, I don't know if you can see that whole thing.
So did you have control over the mustache on the mustache twirl?
Yeah, you can, like some of them, you just have to raise your eyebrows and it does its thing.
Oh my goodness.
Oh, yeah, that's cool.
That's awesome.
Lots and lots of fun.
Yeah.
You got a leech on your lip.
Fantastic. All right. Okay, so who else has something silly to show?
Well, I don't know if this is silly or not. I haven't got the Xbox 360 sensors out again, and
Oh yeah.
I got it up with the Raspberry Pi 3B Plus and tried it on the 4, but I don't know if it's just not being supported as well out there. Couldn't get it up on the Raspberry Pi 4, although it's supposed to be a lot faster, and even the 3, it seems to take several minutes before the image appears. And if you try to run some of the other programs, you completely have to shut down or reset the Raspberry Pi, unplug the Xbox 360 power supply, plug it all back, turn it all back on, plug it in, and then if you're lucky, it'll run the next test program. But it seems very flaky, and I've tried 2 different Xbox sensors, but I only have one power supply, so I may have an issue with my power supply. So the 360s had a separate power supply, whereas I think in the Xbox Ones, it just ran off, whatever power you get from USB, and the external power supply on the Xbox 360 is actually 12 volts, not 5 volts. And that's why I asked at the last RBNB, I guess, if anybody had looked at some of the Intel RealSense sensors. I don't know. Did you say you had, Harold?
No, I haven't, but you may want to ping Ron Dagdag on that. Ping him on either Twitter or not. Yeah, Twitter or whatever. And I think he may have played with that. If not, I bet he knows somebody who does. Because I know I've not played with it. I do remember him saying that stuff, that he's played with it. Because what he's doing now is he's doing some AR, VR kind of thing and that kind of stuff. So his company is getting him the Jetson Nanos or Jetson Xaviers and that kind of stuff he gets to play with. So he gets to play with those toys for work. So I would assume he would be my best person to ask about that. But if he doesn't use one, I bet he knows somebody who does.
Okay. Yeah, they're going down in price. They're like, I think you can get the 435 for I think 167. I mean, these were dirt cheap, but they're getting older now, and You know, these are $10 at Goodwill, and I got the power supply at off of eBay, and that was like 15 with shipping. So, but it seems like the code that's out there isn't that well supported anymore.
That code that did that stuff, Ray, as far as I remember, as far as my memory serves, that code that did that stuff, if it was anything but on a Windows platform, was a total. I want to say a total hack, and I'm not using it disparagingly. What I mean is, it was never ever supported by Microsoft. So whoever did it, it was a reverse engineered thing, and they got tired of it and dealt with it, and just like you said, just don't support it anymore, right?
Yeah. Anyway.
Well, cool. All right. Let's see. Anybody else?
I got a question, opinion question. How do you guys all feel about Nvidia trying to buy ARM? You heard about that? ARM, which builds or designs the architecture for a lot of our processors, is currently owned by a Japanese company called SoftBank, and Nvidia is in negotiations to try to buy ARM. It's quite a controversial move. I don't know what that would mean if all of a sudden because I think ARM is used on even iPhones, isn't it?
Yeah, those little ARM processors used everywhere, man.
Yeah, and if Nvidia bought them, it'd be quite. I don't know. It's kind of weird.
I somehow I don't know if it's necessarily ARM, but just IoT processors in general. I used to do a presentation, and because I got these numbers from someplace else, there's 50,000 of those ARM processors rolling off the manufacturing, going into stuff a day.
Oh, sure.
Literally everywhere.
Yeah. Well, I mean, Raspberry Pis are ARMs, aren't they?
I think so.
Yeah.
I think so.
Yeah.
I know they use a Broadcom chipset to do all the interfaces. I'm not sure what processor is, but I think it's ARM.
It's in any case, thought it'd be kind of an interesting thing for our little world if all of a sudden the world underneath it started to change.
Anyway. To see what they would do with it, since they've got all the powerhouse of GPUs going on. So,
well, that's true. They might. Well, you don't always want to see your world change too much, though.
No.
Sometimes people screw it up.
No, really? I'm not. I noticed that at all.
Yeah.
All righty. All right. So a couple hours in, last call. Anyone else? Anything else to bring up for our monthly meeting? All right, going twice, going 3 times. So cool. Well, guys, it's been a very nice presentation discussion. Thanks again, Ron and Will. It's very much appreciated. Good presentation.
Yes.
Can't wait to see you show us how it's done in the physical world.
Hey, I did send that code, Carl, since I'm rusty on GitHub right now. I emailed you the code to post up on GitHub and the manual, such as it is.
Okay, so what I can do is I'll put it on your behalf up in DPRG somewhere.
Okay.
And well, then I'll put the link out in the meetup, and maybe Doug can mail it or something, or I'll mail it. But
Okay, cool.
Thank you. Thanks again. All right. Well, with that, I bid you guys a great weekend, and Tuesday night we'll meet up again, 7:30 Dallas time.
We'll see.
Sounds good. Sounds good. See you guys.
Take care. Bye.